Hello, hope you're doing well. I'm going to go over the input and output tables handout. So what is the name of the function? The name of the function is that letter in front. So the name of this function is M. The input variable is shown in two places. It's shown here. So M of X is how we read that. And it's also in the rule right there. So the input variable is X. Now, the rule is what changes the input variable to the output value, or the input value to the output value. So that is the rule. So the rule is what changes the input value to the output value. Now let's complete a table. The X part of the table is always the input, and the M of X, or the function notation part, is always the output. So they want me to find 5 inputs and outputs, 1, 2, blank, 3, 4. So I'm going to put the number that would go in the middle, 0. So now I'm going to evaluate the M function with an input of -2. So I'm just going right here and I'm going to input a -2 in the rule where I see that X. -3 times -2 is 6. 6 plus 1 is 7. So that means when the input was -2, the output was 7. Now I'm going to do it with -1. So M of -1 equals -3 times -1 plus 1. Multiply these numbers together, add 1, and that would be the output there. Now I'm going to do it again with 0, 1, and 2. So negative, and I'm going to do them verbally. -3 times 0 is 0, plus 1 is 1. -3 times 1 is -2, plus 1 is -3 times 1 is -3, plus 1 is -2. -3 times 2 is -6, plus 1 is -5. Okay, so that completes the input-output. Let's go on to question number 2. Question number 2 is b of x equals 2 to the x power minus 6. So let's go ahead and name that function. That function is b. Let's identify that input value. Remember that input variable, b of x. That's telling you the input variable is x. And in the rule, there's that x right there as well. The function rule is everything we need to do to that input value to turn it to the output value. So that would be my function rule, and let's now complete the table. Notice it goes 0, blank, 2, 3, blank. So I'm going to put those values in real quick. All right, so now I'm going to input these values one at a time. B to the 0 equals 2 to the 0 power. So I'm replacing that input variable with the value I want to input, minus 6. 2 to the 0 power. Let's go ahead and use our calculator on that. All right, so I'm going to hit 2. The power button is this button right here. So power 0. And I get 1. So then I have 1 minus 6. That gives me -5. So when I had an input of 0, an output of -5. Let's do it again. Let's do it with b of 1. So now let's input a 1. 2 to the 1 minus 6. This one I can do by hand because I know 2 to the first power is just itself. And that gives me -4. I'm going to do it one more time. So I'm going to now do b to the second is 2 to the second minus 6. So I'm going to go ahead and go here. 2, where's that exponent key? Not that one. Exponent key. 2. Notice how I have a little arrow to the right and I'm still in my exponent. I want to drop down from my exponent now because I want to do minus 6. So I'm going to hit arrow to the right, minus 6. Enter. And I get -2. I'm going to do it again with a 3. 2, exponent 3, drop it down, minus 6. And I get +2. And now I'm going to do it with a 4. 2, exponent 4, drop that down, minus 6. And I get 10. So notice how I changed my inputs, and when I changed my inputs, it changed my outputs. Okay, now I'm going to go ahead and do the problem number 3. All right, so refer to the given table. Find f of 9. Okay, so this is the name of the function, And there's that name right there. Notice your input variable is x, and I'm seeing it there and there. All right, so the input variable is x. The input is also always what's in the parentheses. So that's my x value. So my x value equals 9. What I want to do is I want to find the output when I have an input of 9. So these are my inputs. These are my outputs. All right, so I'm going to go to the table, and where I see a 9 on the input, the output is straight across from it. So when there was an input of 9, there was an output of 5. So I want to format this properly. So the f function, because that's the name of it, when it had an input of 9, it gives me an output of 5. And that's the proper format on that. Now, this is the input, and this is the output. So now my goal is to find the input value when I have an output of 2. So I'm going to look on my outputs. So notice how it's f of x equals and f of x here. So these are all the values that f of x equals right here. So f of x equals 2. Boom, right there. The input that gives me that output value is 3. So there's two ways I can write this one. I can write it in function notation. The f function with an input of 3 has an output of 2. Or I can write x equals 3. Both of those are valid. Okay, I'm going to go ahead and flip this over. Problem number 4. All right, I'm actually going to do it on this one if that's okay, because there's no writing it'll sneak through. All right, so this is problem number 4. Let's go ahead and name that function. All right, so that function has a name. That function is d. All right, name the input variable. The input variable, it's d of x. So there's the input variable, and in the rule, there's that input variable. So my input variable is x. The rule is how we change the input values to the output values. So that is my rule. Make a table with 5 inputs and outputs. Between -1 and 1 is the number 0, and after the number 2 is the number 3. So now I'm going to evaluate this function. So I'm going to go over here. I'm going to do d of d of -1 equals -1 squared. So I'm substituting into the rule. Minus 2 times -1. Notice how I'm using parentheses. Always use those parentheses. Now I'm going to let this calculator do the work for me. I'm going to hit clear. Clear will clean up my main screen here. There it is. Open a parenthesis. Remember, the negative and the subtraction are not interchangeable. That's a negative, that's subtraction. So I'm squaring -1. So I'm going to hit the negative. There it is. The squared button, there's 2 ways you can do it. You can just use the exponent key, or there's a special button for squared. I'm going to do that one right there. And then we have -2 times x. So again, I'm just substituting into that rule my input value of -1. And then I'm going to do -1. Remember, hit negative and not subtraction. And now I'm going to hit subtraction because it's -3. Enter. And I get 0. So when I had an input of -1, I had an output of 0. So d of -1 equals 0. Let's see what happens when I put input a 0. I can do this one by hand because 0 squared is 0. -2 times 0 is 0 minus 3. So that just equals -3. Now I'm going to input a 1. So I'm going to do d of 1. I'm going to go up to my rule, and everywhere I see an x, I'm going to replace it with that 1, like so. I'm going to let my calculator do the fun here. Open a parenthesis, -1. Sorry, this is a positive 1, so I'm just going to delete that. 1 squared minus 2 times 1 minus 3. and I get -4. So I'm going to go ahead and put that in my table for my output. See that input of 1 gave me an output of -4. I'm going to do D of 2. I'm going to input that into the rule, like so. I'm going to go ahead and use my calculator. I'm going to open a parenthesis, 2 squared minus 2 times 2 minus 3. And that's -3. So input of 2, output of -3. When I do an input of 3, I'm going to get an output of 0. Okay, so that's the input-output table for function D. Graph the functions in parts in problems 1, 2, and 4 using the tables on the coordinate plane below. Okay, let's do that. Now to do this, I'm going to organize myself really well. So I'm going to go ahead and graph function D first because that table is right there. So I'm going to go where my x is -1 and my y. So input is right here. So this is my input. That's that horizontal number line x. These are my outputs. Now we call them functions d of x, a of x, g of x, f of x, but they really do represent the y value, the output. It's just we like to name them, so we call them functions by name. So the d function and such. All right, so to graph this point or plot that point, -1, 0, go where the input is -1, output is 0. Now I go where the input is 0, output -3. I always go to the input first and then output. So input of 1, right? I'm on the input number line 1. Now I go down to where I would have -4 on the output. So that's 1, -4. 2, -3, 2, -3, and 3, 0. All right, now I'm going to go ahead and draw this graph. I'm looking at the pattern, and that's what mathematics is about, finding that pattern. And the pattern is this bowl shape, and it goes up forever. I know that we only plotted 5 points, but there's an infinite number of points I can put in from this function. I can put in 4, 5, 6, 7, 8, so I got to keep going. So I tell the reader that this graph goes on forever. There's no restrictions on how high it can go up. Okay, that is d of x. Okay, and I'm going to go ahead and highlight d of x. Boom, in pink. All right, now I need to flip this over so I can plot points from one of the other 2 functions because they want me to do 1, 2, and 4. So I'm going to go to 1. Oh, it's not on there. All right, here's my 1 right here. All right, let's go ahead and plot those points. So I'm going to plot -2, 7. So -2, 7 way up here. -1, 4 right there. 0, 1. We call that the y-intercept. This point should have been here. My mistake. 1, -2, and 2, -5. And now I'm going to go ahead and draw that graph. That graph appears to be straight. So I'm going to go ahead and use a straight edge. Again, I know we only plotted these 5 points, but we have to see the bigger picture. And the bigger picture is that you can really put in any number you want. So it's going to go on forever, up and down, left and right. Okay, let's do this last function. Oh, let me go ahead and color that and label it. Here we go. So that's mx is what that's called. And I'm going to do that in yellow. That way I can really see the graphs clearly if I highlight them. All right, now I'm going to go to b of x, and I'm going to plot these points. 0, -5, 0, -5, 1, -4, right there. 2, -2, 3, 2, and 4, woo, 10. That really popped up quick. 1, 2, 3, 4, 10. This one again should have been here. My mistake. Oh, no, that was good. All right, here we go. Now, I know this because I've graphed these before. This graph actually it always approaches that number right there. So -6, but it never crosses it. So here's -6. So I know I'm going to get closer and closer to that point. Oh, there's -6. Closer and closer to that point. And then I'm going to shoot up really quickly. Whoosh, look at that. It goes up so quick. And pretend that's not there. I apologize. That is called B of X. And I'm going to highlight that in orange. Again, you'll see how much easier it is to see it once it's highlighted. Boy, that orange isn't working well, but we're going to make it happen. We're going to make it happen. All right. There it is. I stayed with it. Okay, there's the three graphs. D of X, M of X, B of X. Last question, name the linear function. The linear function is the function that does not make any turns. Notice the orange makes a turn. The pink makes a turn. But notice that yellow one. It never turns. Stays on that same path, straight path. Okay, so the M of X is the linear. All right, good job. Stay strong. That's what's important. And come see us if you need anything. Have a great day.